right, so in our second video today for lesson number 6, this is the only new material for today, and we're going to talk about the sum of the interior angles and the sum of the exterior angles of a polygon. So here's your formula. The sum of the interior angles of a polygon is 180 times n minus 2. And let's just give you an example of it, and then let's talk about why this formula makes so much sense, okay? Let's talk about a pentagon, which is this figure that we have right here, 5 sides. The sum of the interior angles is, according to the formula, 180 times, plugging in a 5 for n, 5 minus 2 is 3, 180 times 3 is 540, right? Sum is 180 times 5 minus 2, which is 3, and the sum is 540. But why? This formula seems like out of nowhere. Why this 180 times n minus 2? And the reason for that is because inside this pentagon, now let me just backtrack a sec. We already know with one figure, a triangle, that the sum of the interior angles is 180. And by the way, it works for the formula, right? Because if you plugged in a 3 for the number of sides, 3 minus 2 is 1, and 1 times 180 is 180. And you may know that the interior angles of let's say a square, which is a quadrilateral, 4 sides, is 360 because the square is 4 right angles. That's 90 times 4, which is 360. And 4 minus 2 is 2. 2 times 180 is going to be 360. So we can see the formula works, but why is it going to work? Well, because it's an application of the 3 angles of a triangle equal 180. You see, if I start with any vertex of this pentagon and I draw in to the opposite points, I'm going to create triangles. Each of those triangles is 180 degrees. So that's where this 180 comes from. But where does the n minus 2 come from? So let me just repeat. The 180 comes from, in each of these 3 triangles, the interior angles is 180. But where does the n minus 2 come from? Well, notice this is a 5-sided figure and I make 3 triangles. How come I only make 3 triangles? Because from any vertex, I can't make a triangle along this opposite point here because it's a straight line. But for all of the other points, each time I draw a straight line, I section or quadrant off an area that's going to make a triangle. I can only do that. I can't do it 2 of the times because of the edge that it makes. All the other times, the ones that are far across, I can create a triangle. And that's why it works. So let's have you try a hexagon. What would be the sum of the interior angles of a hexagon, which is a 6-sided figure? Stop and start. Okay, so 6 minus 2 is going to give you 4, and 180 times 4 is 720. So for a hexagon, 6-sided figure, the sum of the interior angles is 180 times 4, right? Because 6 minus 2, as we wrote right here, is 4. 180 times 4 is 720. But why? Well, look at how many triangles we draw this time. This time we're making 4 triangles. Okay? We have 3 opposite points, and when I draw straight lines to each one, I create a triangle above and below, and then these 2 splits here. So each time you're going to make 2 less than the number of sides is the number of triangles that you're going to make. All right, let's try this question. The sum of the exterior angles of a polygon is 360. Always, always. It never changes. There's no formula to remember. The sum of the exterior angles of a polygon is always 360 degrees. So if you have a square, a quadrilateral, a triangle, a hexagon, it doesn't matter. They're all 360 degrees. Now, why is the sum of the exterior angles of a polygon always equal to 360? Can it be proven? Of course it can be proven. This was the thing I was best at college was proving stuff. A little bit of a personal story here. I hope it doesn't gross you out. But we took this class at Albany State, which was in advanced algebra. And the whole thing that we, sorry about the dog barking. So if you take a look at this particular problem, I was supposed to meet a bunch of my friends over at the campus center, and we were going to go over um, this proof. And the professor said to us, if anybody can get this proof, then I'll give you an A for the class, and you don't have to come to class. Which, hey, who's not going to take that deal? So I went to the campus center, but I got there like an hour late, and all my friends were trying very hard to figure out the proof, and they couldn't figure out the proof. So they gave me the um, the proof to do, and I retired to the men's room. And I came downstairs about 20 minutes later with the proof completely done, and we all handed it in, and they gave us all credit, an A for the course, and we didn't have to attend. So here's the proof of how you do it. The sum of the measure of the angles of a regular polygon on the interior is 180 times n minus 2. So each interior angle is 180 times n minus 2. The individual angle you have to divide by n. Each exterior angle is the supplement to the interior angle. There are n such angles because there are n sides. So if I do a little algebra here, one exterior angle is 180 minus 180 times n minus 2 over n, which is equal to, do a little bit of algebra, split it apart with the n's, and then the n's go die on the 180, so I get 180 minus 180 minus 360 over n. So one exterior angle is 360 over n, and since you're doing the sum of n of them, it works out to 360 every single time. So we'll do some applications of this in just a minute.